AP Cram, Calculus AB, Free Response, Exam Review. Question 37, Trapezoidal Approximation. Train A runs back and forth on an east-west section of railroad track. Train A's velocity, measured in meters per minute, is given by a differentiable function, VA of t, where time t is measured in minutes. Selected values for VA of t are given in the table above. So the question that I want to now pose to you is, at time t equals 2, that's 2 minutes, train A's position is 300 meters east of origin station. The train is moving to the east, okay? So we can pretend that like we're on a Cartesian coordinate. So let's pretend that we have a Cartesian coordinate system, and then this right here, the origin represents origin station. That would mean that the train is moving to the east or in the positive direction on the x-axis, but in this case, the x represents time, okay? All right, sorry for my rough shot drawing. Write an expression involving an integral that gives the position of train A in meters from the origin station at time t equals 12. Use the trapezoidal sum with 3 subintervals indicated by the table to approximate the position of the train at time 12. So pretend that, t equals 12. Falls are right about there. What's going to be the position of the train at that time? I'll give you a moment to think about how to go about summating the trapezoidal approximation, okay? All right, so basically what the trapezoidal rule does is, let's say that our VA of t looks something like this, okay, on a Cartesian coordinate plane. So what we would do is we would make 3 subintervals like we're told, and they would be trapezoids, like so. So there's some spots left out. That's why it's an approximation, and it's not exactly the integral. And the way you find the area of a trapezoid is you take the average of height 1 and height 2, you add them together, you divide them by 2, and you multiply that by the base. So you're going to see this in a little bit, okay? Again, sorry for my roughshod drawings. They're just for explanatory purposes. Just bear with me. So let's call the position of A at 12 S of A of 12, okay? So therefore, it's going to be equal to S of A at 2, t equals 2 minutes, because we're told what that is. We're told that's 300 meters, plus the integral from 2 minutes to 12 minutes of the A of t dt. So from 2 minutes onward and all this in here, okay? All right, so that's that. And so we can go ahead and plug in our 300 because we're given that information here. But we still don't know what the exact integral from 2 to 12 of VA dt is. So this is where we start to use our trapezoidal sum with 3 subintervals. And just for those of you who don't know, when you have 3 subintervals and you're using the trapezoid approximation, the first interval is multiplied by 3. The second interval is multiplied by 3, but the last and final interval is multiplied by 4, okay? And some really smart person did a long proof and figured out that this is what it needs to be, 3, 3, and then you have 4, okay? So the interval from 2 to 12 is going to be 100 plus 4, 40, divided by 2. So these are the two heights, okay? And the heights are just the y values or VA of t values. So here you see your 100 plus 40 divided by 2. So we get the average, which is about 70 times 3. And earlier I had said that the subinterval, some smart person came up with it, but actually this is the width or the base of the trapezoid. So it's like 3 minutes, okay? And then the second interval between 5 and 8 is going to be 40 minus 120 divided by 2. That's the average of the heights, and then multiply by the base. The base is 3 spaces on the x-axis, but here in this specific problem is the time axis, so 3 minutes. And then the last subinterval is 4 minutes long or 4 units wide. So you have 120 minus 150 divided by 2. And notice you're doing the leftmost height subtracted from the height to the right. So this is the way you organize it. When you take the trapezoidal sum, divide that by 2 and multiply by the base, or 4 minutes or 4 units. And then when we add all that up, we get negative 450. But we're still not done. Our position is not negative 450 meters. And the reason why it becomes meters now is because this is an approximation for the integral. And if we were to do the actual integral, we're integrating with respect to time. So that means you're getting rid of the time dimension. And if you get rid of the time dimension for VA of t, you're left with only meters. So this is why this gives us position, okay? So negative 450 plus 300, or 300 minus 450, that's going to be our S of A, because S of A at 12, because this was the original problem. And then that gives you a negative 150 meters. And what that means is from origin station, instead of traveling to the east, this person ended up 150 meters west. You can say negative or the opposing direction, okay? So the position of train A at time t equals 12 is approximately 150 meters, not east, but west of origin station, because it's negative 150 as opposed to 150. All right? I know this was a little confusing. Kind of confused me too, but thanks for bearing